So good to see everybody. I know a lot of you guys had to rush out from whatever you were doing and come all the way over here, so I hope you're able to get a snack and able to look at some of the tables. You also have some time afterwards to do that. But for now, you're going to settle in a bit and hopefully you enjoy the program that we have prepared for you.
Speakers are still have music?
Oh,
yeah, we got music coming.
Sorry. Okay, we'll try to do something with that music.
It's making us all happy. Yeah. So it's nice background.
It's not bad. Okay, I'll go ahead. So my name is Joy Spencer, and I'm part of the editorial board with the SEEE seminar. I'm a professor over at the University of San Diego in the School of Leadership and Education Sciences. I see some of my peeps in the back. Good to see you guys. And thank you guys for coming. This SEEE seminar will be addressing the next generation science standards, what it is and how might it change science teaching and learning. I think that's a really important question.
I'm trying to get the music.
Okay.
Sorry.
There you go.
Ta-da!
Okay. So I know as I read the title of the talk tonight, I think a lot about that. A lot. I'm a math educator. I taught middle school math for many years, and we always think about this gulf between our ideals for what next generation or Common Core can do, and then the realities, right, of what goes on and what happens with teaching and learning. So I think we're going to be really fortunate tonight to hear some conversation, and I want to encourage you to think of questions as you're listening. Be active listeners and think about questions that you might pose to the speakers and questions that you might push back on for us, the people who are on the editorial board with the SEEE seminars, because our goal is not just to bring presenters, but for us to engage in a dialogue, right? For us to be the folks here in the region of San Diego to think about, okay, what does this mean? What do these big policies related to STEM actually mean in the context of learning and teaching? Okay. So to start us off, we're going to be hearing from Dr. Helen Quinn. She's a professor emerita from Stanford University and chair of the National Academy of Sciences Committee that produced a framework for K-12 education, practices, cross-cutting concepts, and core ideas. And I wanted to just say a little bit about Dr. Quinn. And I just learned that we hike a similar spot. I lived in the Bay Area for about 10 years, and there's this hill called Windy Hill, and it is one of the most treacherous hiking paths, and I hiked it twice last April, and it's in her backyard. So we already have a connection. Dr. Quinn was born in Melbourne, Australia. She's a particle physicist whose contributions to the search for a unified theory for the three types of particle interaction, strong, electromagnetic, and weak, were recognized by several honors, including the Dirac Medal of the International Center for Theoretical Physics. She also, as clearly it says here, she has worked with the National Academy of Sciences and helped to produce the framework, a framework for K-12 education, and the notion of practices. And as we were standing in line together getting our snacks, we were already chatting about the idea of how does this framework make itself real in the context of practice. And hopefully she'll speak to that a bit. So if you would please, well, before I ask you to give her a warm welcome, I'm also going to ask to mention to you, you received a goldenrod sheet of paper. Make sure you fill that out before you go. And just to let us know, give us some feedback. But it's my pleasure to welcome Dr. Quinn. Please give her a warm round of applause.
Thank you. I have this mic on. I'm not sure if it works. I'm going to walk around and find out. Yes, it seems to be working. Great. So just before I start, I'd like to have some kind of poll here. How many of you are not teachers? Good smattering. So teachers of teachers? Among those people who said they were not teachers? And how many of you teach elementary school? Middle school? High school? We've got some of each. Well, I hope I can say things that are useful to all of you. And I hope I can find my slides on this computer, which means I will need glasses or some help. I'm completely blind without my glasses. I'm going to start by talking a little history, why we have new standards, what the thinking was of the committee that wrote the framework, and the framework is the basis for next generation science standards. How many of you found next generation science standards hard to read? They're impossible, I think, unless you read the framework first. So I suggest anybody who's finding the standards hard to read goes and reads at least some of the chapters in the document called the Framework for K-12 Science Education, which you can download free from the National Academy Press. So let's see if this now works. Yes. So why do we need new science standards? I submit that there are really 4 reasons. One is that students are different today than they were even 15 years ago. One is that the world is different today than it was 15 years ago. One is that what we know about science is different today. And the 4th is that what we know about science learning is different. So these 4 changes over the past 15 years says it's time to do something a little bit differently. Not completely differently. We build on the experience of the past, but we look to the future and we try to integrate what we know. What about the students do we know? Well, first of all, children today, particularly in urban areas, arrive at school with very different experiences of the world than you had or I had when we arrived at school. Much less experience of the natural world, probably less experience of the mechanical world, probably more experience of technology and media. And so they're coming with different strengths and weaknesses than the curriculum needs to start where they are and move them to where they need to be. So thinking about the child and what the child knows, whether it's a kindergartner or a middle school or a high school student, is an extremely important part of being an effective teacher. And so working from understanding student experience both inside and outside of school is an important thing to think about as we plan and design lessons in science. Secondly, the world. When we say science and the next generation science standards say all students, all standards. Why? Because almost all jobs today require students to have stronger understanding of science, engineering, mathematics, and technology than a generation ago or even 10 years ago. And so technical capabilities to be more employable are important. Secondly, for personal reasons and community reasons, there are many more decisions we make today that require us to have some understanding of how to evaluate scientific evidence, how to understand which claims are based on evidence and which are not, in order to make our decision about what medical treatment to choose or what to do when our society has our community has a problem that it needs to solve. All of these require thinking like a scientist. So we want every student to leave school able to think like a scientist when the problems they face in their life need them to be able to do that. And that's an important goal. And finally, that everybody in the world of modern technology has much more access to information. Information is easy and cheap to find. If you ask a question in a group of people, somebody's going to Google it. Right? So finding information is one thing. Evaluating it, deciding which information is good information, which is bad information, how to interpret the data that's put in front of you, that's what you need to be able to do in the world today. So the difference between a time when information was hard to get, and so you had to learn to remember it, versus a time when information is rich and easy to get hold of, but you have to learn to evaluate and interpret it, is different. And so that's another reason for changing standards. Changing science. When school science subjects were made up in the late 1800s, physics, chemistry, and biology were really different sciences, had almost no connection, and earth science more or less did not exist, right? Today, that's simply not true anymore. There is no biologist today who doesn't think biology is built on physics and chemistry, right? We talk about microbiology, we're talking about molecules. We talk about how do plants grow, we're talking about energy. We're talking about the same principles that appear in physics and chemistry. And the same is true in earth sciences. Earth sciences works by physics and chemistry too, and by biology. Earth science is the most integrative of all the sciences. And so understanding in ways that allow you to make connections across disciplines becomes much more important as scientists work in science today and as children learn science today. So that's another reason for thinking differently about what and how we teach. The issues that we face as a world, as a community, also requires integrative approach. If you're talking about climate change, if you're talking about changes in biodiversity, if we're talking about water and energy supplies for the population, you have to cross disciplinary lines to solve the problems. And so thinking about what does the world need in terms of people's understanding, we need a much more integrative understanding to move forward. And the technology, the connection between science and technology, that new science allows the development of new technology, and new technology provides the tools for new science, is very, very important for the way the world of science works today, and for the world we live in. Understanding the world as we see it today requires understanding how engineering helps us develop technologies, how we can use what we know to design new things, how we depend on things that other people have designed for us. So this is a whole world view that we want students to begin to develop and embrace, starting, actually, my daughter teaches pre-kindergarten, starting in pre-kindergarten, or she teaches